All right, everybody, welcome back. This is Maestro Maravilla, and we're doing Eureka Math. This is going to be lesson number 12. Okay. Lesson number 12, estimating digits in a quotient. All right. So let's get started. To get us going here, we have a division there. We're supposed to divide 150 by 30. Now, we've learned in previous lessons, in previous grades, that you can do 150 divided by 30, right? So this is your traditional long division method, which by this point you should have learned in previous grades. Now, the way we do this is we think, look at the 30, and then we think how many times, it can't fit in the 1. So we get the 5, turns into a 15. 30 still doesn't fit into the 15. So we grab the 0. So now we say, how many times can we fit this 30 into the 150? Okay, so it's 150. So then one way to do it here, one trick, is to eliminate the zeros. So we can eliminate this 0, and we can eliminate that 0. And now we only have a 3, and we have a 15. So how many times can you fit the 3 into the 15? And the answer is 5. Now 5 times 3 give you 15. Take away 15, and your answer is 0. So there it is. There you have it. Your answer is 5. Okay, so another way we can think about doing this is we can say that we are dividing 15 tenths by 3 tenths, right? So 15 tenths divided by 3 tenths. Why 15 tenths? Because 15 times 10, that gives you 150, right? So 15 times 10 gives you 150. And then 3 times 10 gives you 30. So then you can just think, right? You can eliminate the tenths, and now you have 15 divided by 3. And 15 divided by 3, once again, is 5. All right, so we can think about it this way as well. We can also look at it as a fraction, right? We can say 150 divided by 30, right? So it's a fraction, because remember that a fraction is just a division, right? So then what do? Well, once again, we see that the 150 ends with the 0, 30 ends with the 0, same number. We can just eliminate the zeros. And now we have 15 over 3. So now we just simplify this fraction. 15 divided by 3, that will be 5. All right. So this is kind of just a sample so we can begin. All right. So here we are. So then let's go to exercises 1 through 5. So number 1, round to estimate the quotient. Now, quotient means an answer to a division problem. When you see the word product, product means the answer to a multiplication problem. Quotient means the answer to a division problem. So round to estimate the quotient, then compute the quotient using a calculator. So first we're going to estimate. So first estimate, and then we are going to compute using a calculator to find the actual answer. All right, and then we're going to compare the estimation to the quotient. So we're going to compare whatever we came up with an estimation to the actual answer. So first, let's round to 1-digit arithmetic fact and estimate the quotient. Well, if I'm dividing 2,970 divided by 11, well, I can round 2,970. So this is what we're doing, right? So first of all, we're doing 2,970, and then this is going to be divided by 11. All right, so we have that. So, but I think it'll work out better if we actually just estimate, right? So then 2,970 can be rounded up to 3,000. Divided by 10 can be rounded down to 10. Okay. Now we are going to go ahead and eliminate one of the zeros. So we're going to eliminate the 0 on the outside, 0 on the inside. Now I have 300 divided by 1. How many times can I fit this 1 into this 300? Well, the answer is 300, right? So I can fit it 300 times. 300 times 1, take away 300, and you got a remainder of 0. So then we can say, I can say that my estimate, right? My estimate, let's say that it's 300. Okay, that's my estimate. Now it says use a calculator to find the quotient, to compare the quotient to the estimate. Okay, so then we have 2,970 divided by 11. Okay, so that's what we have. So what's the actual quotient? So the actual quotient is, let's pull up a calculator here. Okay, I'm gonna bring this calculator. All right, so we're gonna say 2,970 divided by 11. And what's our answer? Our answer is 270. So there's the actual answer. You can see here that my actual answer, the quotient, actually it's not that far apart from the 300. So we can say that the quotient is very close. Right? It's very close to the estimate. All right. Okay, so that's our first example there. Okay, so number 2. Number 2, we've got 4,752 divided by 12. So we've got 4,752 divided by 12. Okay, so now round to 1 digit, arithmetic fact, and then estimate the quotient. Okay, so what do we do? So first, let's go ahead and do the rounding. So to make this simpler. So 4,752, I'm gonna go ahead and round them up to 5,000. And then 12, I'm gonna go ahead and round it down to 10. So that makes it easy, okay? So then what do we do here? Well, once again, this 0 on the outside can be eliminated if I eliminate a 0 in the inside. And now my new division problem is going to be 500 divided by 1. And I already know that 500 divided by 1 is just 500. So we can say that my estimate is going to be 500. Now let's actually get the quotient using a calculator to see how close or how far apart we are to the actual quotient. So let me bring up a calculator. Okay. Okay. And we're going to say it's 4,752 divided by 12. So 4,752 divided by 12. Okay, and then my answer there using my calculator is 396. That's my actual quotient. So when we compare them both, we can say that the quotient is close to the estimate, but then it's close but not that close, right? Because from 396 to 500, that's about 104 difference. So it's kind of close, but not that close. So we can say the quotient is close to the estimate, but not as close as the estimate, not as close as the estimate in the first example or in the first exercise, right? And this is because, again, there is quite a little bit bigger of a separation from 500 to 396 versus in the previous example, 270 was much closer to 300. Okay. So let's move on to number 3. Okay, so number 3. Round to 1 digit arithmetic fact, estimate the quotient. Okay, so we had 11,000. Got 11,647. And this is going to be divided by 19. Okay, so 11,647, it's probably easier if I round it up, because notice that the third digit is 11,000 and then the third digit is a 6. So then I can round up to 12,000. And 12,000 divided by, well, a 19, it's easier to round it up to a 20. Okay? And now that I have it this way, I can eliminate 1 0 on the outside, 1 0 on the inside, and my new division will be 1,200 divided by 2. Okay? So that's my new division. Then I'll say, how many times can I fit the 2, this 2, into the 1? The answer is 0, right? I can fit it 0 times. So then I'll have to look at the next number and put it together with the 1, and that'll turn it into a 12. Okay, so I'll turn it into a 12. So then how many times can you fit the 2 into the 12? The answer is 6. Why? Well, because 6 times 2 is 12. So you take away 12. Okay, so the answer is 0. Okay, so 6 times 2 is 12. Take away 12. 12 minus 12. Right? 12 minus 12 is 0. But you got to bring back down one of those zeros. Now you say, how many times can you fit the 2 into the 0? The answer is 0. How many times so then now you got to bring down the last 0. Bring it down. And now how many times can you fit the 2 into the 0? The answer is 0. So there's my answer. My answer is 600. The 0 to the left doesn't have any value. So my answer is 600. So then I can say that my estimate is 600. Okay, that's my estimate. Now we're going to actually, it says right there, use an actual calculator to find the quotient and compare it to the estimate. Okay, so let's bring up a calculator. Yeah. All right. Bring up a calculator. So I have 11,647. All right, so 11,647 divided by 19. So it's going to be divided by 19. And what do we get? Our answer is 613. Notice that in this case, the estimate and the actual quotient, the actual answer, they're much, much closer. So then we can say that the quotient is actually very close to the estimate. Okay. In general, you will see that when we're estimating, the closest your estimation is to the actual number, the more accurate your answer will be. Notice that in this one, 5,000 is about 250 units away from 4,752. And then the 10 is 2 units away from the 12. So the estimations here are a little further apart, and that's why your estimate and your actual quotient are a little bit much far apart. They're not that close. It's close, but not that close, right? Whereas if your estimation is much closer, right, then your answer, the quotient, will be much, much closer to the actual answer. So the closer your estimations are to the actual number, then the more accurate your answer will be. Okay, let's go to number 4. Number 4, I got 40,644 divided by 18. So 40,644 divided by 18. But see, I have to round the numbers up or down so that I have even numbers. It's easier for me to estimate. So this 40,644, it's easier if I round it to just about 40,000. Divided by 18, it's easier if I round it up to about a 20. Now, remember, this 2, the 0 and the 2, the first 0 on the outside, I can eliminate it if I eliminate 1 0 on the inside. So now it's going to be 4,000 divided by 2. And I can just do my long division here, right? So 4,000 divided by 2. I say, how many times can I fit this 2 into the 4? The answer is 2. Then I say 2 times 2. That would give me 4, so I take away 4. Okay, then 4 minus 4. My answer is 0. So then I bring down the 0. And then I say, how many times can I fit this 2 into the zeros? The answer is I can fit it 0 times. So then I say 0 times 2 is 0. So you take away 0. You have 0. So then you bring down this other 0. Bring it down. Then you'll say, okay, how many times can this 2 fit into the zeros? The answer is one more time, 0. 0 times 2 is 0. So you take away 0. And then you bring down the last of the zeros. Okay. And how many times can you fit the zeros into 0? 0. 0 times 2 is 0. So you take away 0. And then there's your answer. And your final answer there is 2,000. So we can say that our estimate can be 2,000. Okay. That's our estimate there. Better? All right. So then let's go ahead and pull a calculator and see what the actual answer is. So once again, I am actually dividing 40,644 by 18. So let's bring down a calculator. Okay, let's open it up. And we have 40,644. Okay, and that's going to be divided by 18. And what do we get? We get 2,258. This is the actual quotient. Okay, so look at the actual quotient, my actual answer, or my estimation. Okay, and so we can say that the quotient is close, but it's not as close as this one back here. This one was really close. And once again, it has to do with the fact that my estimations are closer to the actual numbers. That's the reason why. Okay, again, my estimations are much closer. So then we can say that the quotient, okay, the quotient is close to the estimate, but it's also not as close to the third example, the previous one. Okay, so we can say that. Okay, so let's go to number 5. Okay, for number 5, let's do a couple of different estimations. Okay, based on different combination of rounding, because you will notice that the 15, right? When you have a 1, a 2, a 3, or a 4, usually we round them down, right? So if you have 11, 12, 13, 14, you round them down to 10, right? If you have 16, 17, 18, or 19, then you can round them up to 20, right? But when you have a 15, I mean, you can go either way, right? You can come down to 10, or you can go up to 20. So we can try both ways and see what kind of different answers we'll get. So first of all, we're doing 49,170 divided by 15. Or remember, because we're gonna go up and we're gonna come down and go up. So once again, 49,170 divided by 15. Okay, so let's see which one is closest to the actual quotient. We're gonna round down and we're gonna round up. First, let's round down. So this 15, I'm gonna round it down to 10. Round it to 10. And then 49,170 can be rounded to 50,000. That would be the easiest. 50,000. But on the right side, this 15, we can actually round it up. Remember, because it's 15 to 20. And then the 49,170 again could be rounded to 50,000. So see what kind of different estimates we get here. Okay, so then what we're gonna do here then is this 0 and this 0 can be eliminated. So then I have 5,000 divided by 1. So then the 1 fits into the 5,000 times. So here my estimate could be 5,000. Okay? Now let's look at the right side. On the right side, now you know, right? Again, this 0 and this 0 can be eliminated. So then I'm going to have 5,000 divided by 2 this time, not by 1. So then I'll say to myself, okay, how many times can you fit this 2 into the 5? The answer is 2. Okay, 2 times 2 will give you 4, so you take away 4. Okay, so then 5 minus 4 will give you 1. You bring down the 0. Then you'll say, how many times can you fit this 2 into the 10? The answer is 5. So then you'll say 5 times 2 will give you 10. So you take away 10, 0. You bring down the 0. You can fit it 0 times. Same with this other 0 here. You're going to be able to fit it 0 times. So then you're going to have about, so your estimate here is going to be 2,500. Okay. So one thing that I do want you guys to note is that obviously my estimate here is 5,000 and my estimate on the right side is 2,500. But these numbers, you know, my actual division is 49,170 divided by 15, right? That's my actual division. So this 15, we rounded up to 20 in this example, but on the left side, we went down to 10. The 49,170, we kept it at 50,000 on both sides. We could have actually come down to this and called it a 40,000. But if you call it a 40,000, it's further away from the 49,000. So the answer you get, the estimate you get, if you make this a 40,000, round it down to 40,000, it's going to be closer. I mean, it's going to be further apart to the actual quotient. So remember, the closer your estimation to the actual numbers, the closer you'll get to the actual answer, the actual quotient. So now you can say here that your estimates, they vary. So it could be anywhere from 2,500 to 5,000. So your answer is somewhere in between those two, right? It could be as little as 2,500 or as much as 5,000. The answer is going to lay somewhere in between. So let's actually use an actual calculator to calculate 49,170 divided by 15. What do we get? Let's bring up a calculator. Okay, so we're going to get 49,170. And then we're going to divide that by 15. And what do we get? Okay, so we get 3,278. So you can see that the actual answer, it's in between 2,500 and 5,000. Okay, so that's what we did. So we can say that the quotient is kind of somewhat close to the estimate, but it's really not as precise, right? So again, we can say the quotient, actually, I think it would be good to say that the quotient is somewhat close to the estimates. We can say that, but then we can also say, but remember, however, it's not as accurate as previous exercises and examples where the divisors were closer to a multiples of 10. In general, I can say, in general, the closer the estimate to the number, then the closer it is to the actual quotient. Okay, so we can say that in general. All right. On the last example here, example number 3, let's try to get as close as we can to the actual numbers with our estimation so that we can get a closer an answer or an estimate that's closer to the actual quotient. So we have 918 divided by 27, right? So then we would write something like this, 918 divided by 27. Now again, we're going to estimate as close as possible as we can to the actual numbers. The 27, we can probably round up to 30. And the 918, we can round it to 900. But if we actually round it to 920, so the 18 turn it into a 20, then our answer will even more closer to the actual quotient. The estimate will be closer. But in this case, I'm going to keep it simple. So I'm just going to keep it at 900. So then once again, I'm going to remove one of the zeros. And now my new division problem is 90 divided by 3. So then how many times can I fit this 3 into the 9? The answer is 3. 3 times 3 is 9. So you take away 9, gives you 0. You bring down the last 0 there. Now you say, how many times can you fit this 3 into the 0? The answer is 0. And now 0 times 3 will give us 0. So you take away 0 and the answer is 0. So here, my estimate there is 30. So then we can say that my estimate is going to be 30. But what happens if we actually do the actual, let's try the long division with the actual numbers and see what happens. All right. So then I'm going to have to do 918 divided by 27. Now, one trick that I'd like to do, because it's not as easy to figure out how many times is the 27 going to the 91. It's not as easy to see than as it is to see 30 into the 900, or even easier, 3 into the 9, right? So estimating gives us like a quick look at what the answer more or less is going to be. So we should know that it's going to be around 30, more or less close to 30, okay? But one trick we can do is we can do this. So what I'm going to do is I'm going to add 27 plus 27. So then 7 plus 7 is 14. Carry 1 over. 2 plus 2 is 4. Plus 1 is 5. Okay, now remember, this 27 obviously doesn't fit into the 9. So we're looking at a 91. So how many times can this 27 fit into the 91? Okay, 54 is still too small. So we're going to add one more 27. Okay, so now 7 plus 4, that's 11. Carry 1 over. 1 and 5 is 6, and 2 is 8. Okay, so that's closer. That's actually closer to 91. 81 is closer to 91. If I add another 27, it's going to go over 91. So then I can therefore conclude that 27 fits into the 91. How many times? How many times did I add the 27? I added it once. I added it twice. I added it 3 times. So it fits 3 times. And I already know that 3 times 27 is just the addition of 27 3 times. 1, 2, 3. And therefore it's 81. I already have my answer there. So you take away 81. 91 minus 81, you have a remainder of 10. Now you bring down this 8 right there. Now you say to yourself, how many times can the 27 go into the 108? Well, look, we are already at 81 with 3 times. So what happens if I add another 27? Let's see what happens. So 1 plus 7 is 8. And then 2 plus 8 is 10. And look at that. They actually match. Look at that. So therefore, I can fit it once, twice, 3, 4 times. So 4 times. And I already know that 4 times 27 is 108. Because I already did the math right here. So then you take away 108. And your remainder is 0. All right, so in summary, the closer your estimation is to the actual number, then the closer your answer will be. All right, that's it. See you guys next time.